This is Prashant. Now today I am going to start with reflection of light, that is standard 9th chapter. I will go this chapter. I am not going each and every part. The important part which is important for exam point of view, that only I am going to discuss, right? Okay, now what is reflection? So we'll take first, this is my plane mirror. This is my plane mirror, say M1, M2 is my plane mirror. On this plane mirror, say this is my incident ray, incident obliquely. This is my incident ray. This is my incident ray. Now here is a normal drawn. This is a normal drawn. Then this light gets reflected back over here. This is a reflected ray. This will be your reflected ray. This is the reflected ray. This is the normal given. This is what is a normal. Now, I is the angle of incidence. This is the angle of incidence. This is the angle of reflection. R is the angle of reflection. Right? So I will write here. This I is the angle of incidence. Then R is the angle of reflection. And what is this angle theta? I am calling this angle as what? Theta. So therefore this is also theta, right? This theta is called as glancing angle. It is called as what? Glancing angle. Now what exactly is the glancing angle? This angle is angle made by incident ray with the surface. It is the angle made by incident ray with surface. Now this theta can be written as 90 minus I. So I can write here therefore I plus theta is equal to 90 degree. So I can write therefore I is equal to 90 degree minus theta. That will be your angle of incidence. Right? Now we have what are laws of reflection. We have important part. First question. What are laws of reflection? Now, in case of laws of reflection, there are two laws of reflection. First law, your angle of incidence is equal to angle of reflection. First law is what? Angle of incidence is equal to angle of reflection. Second law is your incident ray, right? Normal and reflected ray. Incident ray, this is my incident ray, this is normal, and this is reflected ray. They all lie in same plane. They all lie in what? Same plane at the point of incidence. They all lie in what? Same plane in the point of incidence. This is about the laws of reflection, right? Okay. Now we'll come to the next part. What exactly is the next part? Now, if they asked what is a normal incidence, so what we have done was oblique incidence. Now this is my plane mirror, right? On this plane mirror, suppose this is my incident ray. This is my incident ray. The ray gets reflected back in the same direction. So this is called as normal incidence. It is called as what? Normal incidence. And for normal incidence, your angle of incidence, angle of reflection, both will be 0. In case of normal incidence, angle of incidence and angle of reflection both will be 0. Now many students are writing angle of incidence and angle of reflection both are 90. So not 90. It is, what is angle of incidence definition? It is the angle made by incident ray with the normal. So over here this is the normal and incident ray makes an angle 0 degree with the normal. Therefore angle of incidence and angle of reflection both will be 0. Right? Okay. Now there are two types of reflection. One is regular reflection. This is my regular plane mirror. And second will be irregular reflection. This is again mirror but not plane. It is a curved mirror. Suppose this is these are my incident rays. This is first, this is second, and this is third, right? These rays get reflected back over here. This is first reflected ray, second reflected ray, this is third reflected, right? So over here the intensity of image form will be of same intensity. But if suppose this is my incident ray over here, this is the second incident ray over here, this is the third incident ray over here, this light gets reflected back like this. This is first, this is second, and this will be the third, right? So over here the light obtained will be a diffuse light. So over here this light gets scattered in all possible directions. So the image form over here will be irregular reflection beam. It is diffused image. Diffused image is obtained, right? Okay, we'll go with the next part. Now what is next part? Next part will go with what is lateral inversion. Now lateral inversion is nothing but it is the interchange of left and right side in the image of an object in a plane mirror is called lateral inversion, right? So we'll go with what is lateral inversion. It is lateral inversion. So for that part I will take, this is my plane mirror. This is my plane mirror. Right? This is my plane mirror. Let M1, M2 be plane mirror. Now over here, let's say this is my object. This arrow is my object. I will call this arrow, say AB is my object. Right? Now what I will do? I will select this point. I will take the perpendicular distance from this point A to mirror. Exactly that distance I will mark over here. Here will be my image A dash. Here is distance, this distance, exactly this distance I will mark over here. This point will be my B dash. I will join these 2 points. I am joining with this. This will be the image form. So first I will write here, this is the image. Object, dark line, image will be dotted line. It is virtual. Image form in a plane mirror is always virtual image. Now from here I will draw 2 rays. This is first incident ray. This is second incident ray. Right? I will join this part with this A dash. I'm just joining this part with this A dash. Right, I will continue this part over here. I will just join this part over here. It will just continue like this. This is the reflected ray. Right? Second ray is incident from here. This is my incident ray. This is the second incident ray. Right? This will be the reflected ray like this. This will be the reflected ray like this. Right? So this is my incident ray, this is my, this is my object, this will be my image. So this is called as lateral inversion. This is called as lateral inversion. Right? Now, same diagram I can modify with the help of letter P. So in same diagram, I can go with, this is my letter P. Right? So how to draw this diagram over here? Remaining part will remain as it is. Only this part will get changed. This will be the part. This part will be image, which is dotted. So this is my object. This will be the virtual image obtained in a plane mirror. This is called as lateral inversion. Now then you have a give reason type question. Why it is written, ambulance word is written in laterally inverted in the front of any ambulance. If 2 mirrors are placed in such a way that, say case 1, theta is the angle between 2 mirrors, then the number of images formed will be n, which is equal to 360 degree upon theta. Theta is the angle. If this answer comes out to be odd number, answer odd number hai, then we have 2 more cases. If the object is placed asymmetrical, number of images will be n, and if the object is placed symmetrical, then number of images will be n minus 1. Right? Suppose this number comes out to be 7. Then if it is asymmetrically placed, I will write 7 only. But if it is symmetrically placed, I will write 7 minus 1, which is equal to 6. Right? This is case 1. In case 2, if theta is angle between two mirrors, then number of images is n is equal to 360 degree upon theta, which is, suppose that number comes out to be even number, then number of images is equal to n minus 1. Suppose this number comes out to be 4. 4 is even number, so the number of images formed will be n minus 1, which is equal to 3. Right? This is about the angles. Right? Now we'll go with the actual two diagrams. What are the two important diagrams? When two mirrors are parallel and when two mirrors are placed perpendicular to each other. Now check first part. If two mirrors are parallel to each other, then infinite images are formed. How many images are formed? Infinite images are formed. Check how that infinite images. You have n is equal to 360 degree upon theta. But when two mirrors are parallel, means theta equal to 0. This is 360 upon 0. Anything upon 0 is 1 upon 0 is infinity. Therefore, how many images are formed? Infinite images are formed. And check. These are two parallel mirrors. So this is first mirror. This is my second mirror. Right? Now in practice, what will be the width of these two mirrors? That is very important, because this is I am drawing on board. So for you, that measurement has to be fixed. So first of all, these are two mirrors, plane mirrors. So I will call this is M1, M2, N1, N2, N2. And these are two mirrors. Now say this is a one standard line. This is the standard line I am keeping. Now here, say this is my object. I will write first this I will draw. This is my incident ray, first incident ray. This is my second incident ray. Right? I will call this point as A. Right? I will take distance OA. Whatever, suppose this is 4 centimeter, is equal to this. I will mark same distance, which is equal to IA. Is equal to IA. So what I will take? Whatever distance I am measuring over here, I will take the same distance. I will mark that point as I, and then I will join this part with the help of dotted line, and I will continue. I will just join this part with a dotted line, and I will continue. I will just continue this part. This is a reflector ray, right? This is your first ray. Now, second, I am selecting this point as B. So now what I will take? I will take BI is a distance. I will take this distance. This is BI. I will mark the exact same distance. This is BI. I will mark this distance, same distance over here, with BI1 is equal to BI. Exactly same distance is required. It should be point to point, not a 1 millimeter difference also allowed. Then I will join this part with this 2 points. I will join this part with the 2 lines. This is first. This is the second. Right? This is first and second. In this way, for third case, I will take this distance. AI1 is equal to whatever that distance, but it is not practically possible for you to draw on board or on book. Right? So in this way, infinite images are formed. What you have to take precaution with this distance, that is OA is equal to I. this bi is equal to bi1, this distance has to be equal, then you can find infinite number of images are formed. Now what are the frequent mistakes done by a student? So when we draw this plane mirror, they will not give this shading part. The shading part is very important. Then when they draw this diagram, these parts are dotted, these images are dotted. So they are showing the dark part. Here they are missing that arrow. If you miss any arrow in ray diagram, you will get 0 mark. It is very important. Arrows are very important, right? This is about the when two mirrors are parallel to each other. Now, next part, if two mirrors are again say perpendicular to each other. So if two mirrors are instead of parallel are perpendicular. Two mirrors are perpendicular to each other. Then how many images are formed? It will be 3. How 3? This is 360 upon 90. This is 1 za, this is 4 za. But 4 is an even number. Therefore, number of images will be n minus 1 is equal to 4 minus 1, which is equal to 3. So 3 images are formed when two mirrors are perpendicular to each other. Right? So how to start with that perpendicular mirror? So for that, I will take a circle with a dotted circle. Right? This is my dotted circle of particular radius. This should cover your half page. This circle should cover your half page. So this is dotted, so I will just remove this part. So all this part is dotted, right? This is dotted circle. Now I will select, this is a center, these are two mirrors, they are perpendicular to each other. This is not mirror, this is not mirror, these two are mirror, this is first mirror, right? This is second mirror. They are perpendicular to each other, right? These are perpendicular to each other. Now I will select this point. Suppose here is a point. I am selecting say P is my point, right? I will just take one line. I will just join this part with this. I will just join this part with this. I will just join this part with this. And just join this part with this, right? So either you will get a rectangle or a square, whatever it may be. It could be either rectangle or it could be square, right? Next part me, I will start from here. I will draw two rays. One is this ray. This is my first incident ray. This is my second incident ray. These are two incident rays. Now I will join this part. This is P. I will call this is P1. Here it is P2. And here it is P3, bracket P4. P4 is overlap. Right? The first ray will, suppose this is my incident ray. So instead of coming this mirror, it could incident on this mirror. The image will be P1. So over here it is incident. So I can say this will be the image form. And it will continue like this. It will continue like this. Right? This is first reflected. Now after that it will join this part over here. Just join this part over here. It will continue like this. It will join like this from here. It will go like this. And it will continue. So here how many images are formed? It is, this is first, second, and this is third. I will write this is first, second and third. Third is overlapping. Therefore we can have 3 images are formed when two mirrors are perpendicular to each other, right? This is very important. Here I will write now I. This will be your I, right? Okay. Now we will go with the next part, that is ray diagrams in case of concave and convex mirroring. Right? That is very important part and last part of this chapter. Okay, check it properly. Now there are two types of curved mirror. There are types of mirror. There are two types of curved mirrors. One is called as concave mirror, and second will be convex mirror. Second will be convex mirror. First is concave, second will be convex. Now what is concave mirror? So this is your concave mirror whose outer part is silvered, right, and this part is polished. Inner part is polished and outer part is silvered. That is called as concave mirror. In case of convex, what is there? Your inner part is polished, and inner part is polished, and so it is inner part is silvered. I'm so sorry, it is silvered, and outer part is polished. Outer part is polished, right? This is a principal axis. This is pole, right? This is the pole. Now this is a focus. This is the center of curvature. This distance CF and PF has to be equal. Similarly over here, this is the principal axis. This is the pole. This is your focus. This is the center of curvature. Now any ray coming parallel to principal axis. So this is my first incident, right? Will pass through this mirror, pass through this concave mirror through focus after reflection. Will pass through focus after reflection. This is first incident ray. Similarly, this is my second incident ray. This is my second incident ray. Then after passing through this, it will pass through focus. This is the second reflected, right? This kind of image will be formed in case of concave. Now here, if suppose rays are coming parallel to principal axis, this is the principal axis, then the reflected ray will pass through this with a dotted line. Over here, it will go down, and I will join this part with C, because over here that line drawn is a normal, right? Any line passing over here, this line is called as normal. This line will pass like this, is called as normal. So this is your angle of incidence, this is your angle of reflection. Similarly over here, this is the line passing through this is angle of incidence, angle of reflection. Both are equal. So over here, this is my angle of incidence, this is angle of reflection, right? Similarly, if ray is incident from here down, this is my incident ray. After this, it will pass through focus. As I pass through, it will go like this, and I will draw this line over here. This line drawn will pass through this. So this is my angle of incidence, angle of reflection, right? So this is about the concave convex basic diagram. Now I will go with the cases in case of concave. Right? Around 7 cases are there, and 1 case in case of convex mirror, right? We'll go step by step and just discuss about the characteristic of the image form, right? Otherwise we will not do anything else, right? Just check all ray diagrams. Now in case of concave, so I write here for concave mirror, is concave mirror. First case, case 1, when object is at infinity, right? When the object is at infinity. Same, this is my concave mirror. This is the thin concave mirror. Say M1, M2 is my thin concave mirror. This is the principal axis. This will be the pole, right? This is the pole P. This is focus. This is center of curvature, right? Any ray which is coming parallel to principal axis, because object is at infinity, after reflection, it will pass through focus. This is the first incident ray get reflected. Here will be the second incident ray. Light is coming parallel to principal axis. After this, it will pass through this. This is the image form. Here will be the image form, right? So the image form have a characteristic of real, because actual intersection. It is inverted. It is inverted, and it is diminished. It is diminished to a point. So image form over here is real, inverted, and it is diminished to a point. Right? This is about the first ray. Now we'll go with second. When objects is at, this is case 2, when the object is at far distance. It is far distance. It is distant object, far distance. So over here, this is your concave mirror. Right? This is your concave mirror. We give name M1, M2. This is the principal axis. This will be the pole. This is your focus, which is F. This is center of curvature, which is C. Now the first ray will incident like this. It will pass through P. Just take the angle, what exactly angle. With the same angle, this ray get reflected, right? This is a reflected ray, like this. Now from F, I will check this F up. From F, draw one line in vertical downward direction. This will be your image A dash, B dash. This will be your A dash, B dash. Now draw one more ray parallel to this incident ray, obliquely incident. This is my incident ray, right? It is parallel to this incident ray. After this, it will pass through A dash. So this is the reflector ray, right? So the image form, this is the image form. So I can write image will be, it is real because actual intersection, it is inverted as compared to your inverted with the object, and it is highly diminished. It is what? Highly diminished. So these are the characteristic of image form, right? This is about the second ray diagram. Now we'll go with third ray diagram. What is third case say? When your object is beyond C, when the object is placed beyond C. So again, this is my concave mirror. This is my concave mirror, right? This is the principal axis. This is pole. This is focus. This is C, right? Your object is placed. This is my mirror M1, M2. Your object is placed here. It is beyond C. AB is my object. First ray will go parallel to principal axis. This is the first incident ray. It will go parallel to principal axis. This is my girdle upward. It should go like this. It should be parallel to principal axis. After this, it will pass through focus. It will pass through focus. I will just shift this focus. This is the reflected ray. Right. Second ray will pass through focus. It will pass through focus. This ray will pass through focus. Right. And after that, it will go parallel to principal axis. It will go what? Parallel to principal axis. So the intersection of these two will be the image form, which is your A dash, B dash. So A dash, B dash is your image form. So it is real, yes. It is inverted, yes. And it is diminished. It is diminished as compared to object. You can't write highly diminished. It is just diminished. So you have characteristic real, inverted, and it is diminished. Right, this is about the third case. Now we'll go with fourth, case 4. When the object is at C. When the object is at C. So here, this is again frequently asked question. This is your plane, or concave mirror. This is say M1, M2 is your concave mirror. This is the principal axis, right? Just take down, lateral down. So this is my principal axis. This is pole P. This is focus F. This is center of curvature C. Right? my object is placed over here. This is my object. I will take this is my object. Say AB is my object. I know that when the object is placed at C, image is also formed at C. So I will take the image of same height, that is A dash, B dash, same height. I will join this part. These two rays are parallel to principal axis. It will pass through focus and it will meet here. Similarly, second ray will pass through focus. It will pass through focus, and after that it will meet somewhere here. So these are the this is the image form. What is the characteristic? It is real, it is inverted, and it is same size. It is what? Same size as that of object. So characteristic will be real, inverted, and same size as that of object. Right? Now we'll go with the next. When object is placed, that is case number 5. Case number 5. When object is placed between C and F, between focus and center of curvature. So here will be the concave mirror. This is a M1, M2. This is the principal axis. This is pole B. This is focus. This is center of curvature C. Right? Object is placed over here. This is my object placed. AB is my object. This is the first ray will go parallel to principal axis. Right? I will take it lateral down because it is not coming directly parallel. Second ray will pass through focus. So this is a ray will pass through focus. It gets reflected like this. Second ray will go through focus. Right? After passing this, it will go like this. It will go parallel to principal axis. Then they meet at this point. So here will be the image A dash, B dash. Right? Now compared to object, size of image is little bigger. So I can say it is real, inverted, and it is magnified. What is the characteristic of image form? It is real because actual intersection. It is inverted with respect to object, and the size of image is little more. Therefore, it is magnified. Don't write highly magnified. It is just magnified. Right? This is about case 5. Now we'll go with case 6. In case 6, when object is placed at F, the object is placed at F. So here, this is my concave mirror. I will write M1, M2 is my concave mirror. Right? This is a pole. I will write this is principal axis. This is pole. This is your focus. This is your C. Now my object is over here. This is my object. This is my object AB. First ray will go parallel to principal axis. After that, it will pass through F. This is my first ray. It is going parallel. Second ray, it will pass through. See, I will join this AC with this. So this ray, this gets reflected back, and it will pass like this. So these two rays are parallel to each other. So the characteristic of image will be real. It is inverted, and it is highly magnified. Characteristic will be real, inverted, and highly magnified. This is very important type. Now we'll go with last diagram of concave mirror. That is case 7. When object is placed between F and E, focus and O. Object is placed between focus and O. Now this is your concave mirror. I will call this is frequently asked question. M1, M2. this is the principal axis, this is pole, this is your focus, this is your center of curvature. Now object is placed over here, this is my object, AB is my object. In case of this object, first ray will go parallel to the principal axis. It will pass through focus, right? And over here it will go dotted line. This is the dotted line. Second ray, I will join this AC. I will just join this AC. This is point A. I will just join this AC over here. Right? This is the AC. This incident, it gets reflected. I will just join this part over here. I will just join this part. Continuing over here. This is the point of intersection where image A dash and B dash is formed. So the characteristic over here form will be, it is virtual, erect or upright, and third will be virtual, erect and magnified. It is magnified. Virtual, erect and magnified. These diagrams are very important with this dotted lines. So just take care. This is the only case where virtual, erect and magnified images obtained, right? In case of concave mirror. Now we'll go with the last diagram of convex. Only one diagram. That is in case of convex mirror. So write here for convex mirror. When object is placed in front of it, cases when object is placed in front of it. So this is my concave mirror, sorry, not concave, it is convex mirror, M1, M2. This is the principal axis, this is the pole, this is your focus, this is your center of curvature, right? I will consider this is my object, so this is my object, AB is my object. First ray will go parallel to principal axis, this is the first ray. After this it will pass through this, and after this it will pass through this, and it will reflect like this. This is the first reflected. Second ray, I will join this AC. So for that I will join this AC. Right? It will go like this. It will meet over here. This is the point where it meet. It get reflected back. The point of intersection of these two will be your image A dash, B dash. Right? So the characteristic over here, it is virtual, erect, and it is diminished. Characteristic of image will be virtual, erect and diminished. Now that's it for this video. Friends, please subscribe my channel if you want, because it will help you to get more videos regarding physics, and please do comment. If you comment, then I will come to know which topic is required. This I am making as per my requirement. If you want something else apart from this, please do comment on that. Thank you so much.